All right. Welcome, everyone. This is Jill Lackett and Brian Miller at the North Central Climate Science Center, and this is the Adaptation Working Group webinar. Let's see. Brian will be presenting today with Nick as well. Amy just found out yesterday, I believe, about a prescribed fire that she needed to be out, so she's not going to be joining us today. But Brian Miller is a research ecologist here at the USGS in Fort Collins, and I will let him introduce Nick, but they're going to be talking today about their scenario planning project, and the title of their presentation is Quantitative Modeling and Participatory Scenario Planning, Complementary Tools for Climate Change Adaptation. So when you're ready.
Jill. So yeah, again, this is Brian Miller here at the North Central Climate Science Center, and I just wanted to briefly introduce Nick Kelly, who is the Forest Ecology Program Director at the Schoodic Institute at Acadia National Park. And for those that are wondering how Nick got involved in a project in the Dakotas when he's working out in Maine currently, for those who don't know Nick's background, he was previously at the National Park Service in their climate change response program. And so when this project was initiated, he was working there, and so that's how we kind of got things started. And he's since sort of moved over to Schoodic, but we continue to work together on this project and really seeing it through to completion. So we're happy to still be able to have Nick on board and really helping us to finish it out. So with that, I'll pass it over to Nick, and you'll hear from me a little bit later in the presentation.
Hi, thanks, Brian, and thanks all for coming. And Brian, thanks for letting me continue to work with you on this project, even though I am no longer in the North Central region. So I will take over Amy's few slides today while she's out having fun with fire. So this presentation is part of our larger Scaling Climate Adaptation in the Northern Great Plains project, which is funded through in part through the North Central Climate Science Center. And today I'll focus on Southwest South Dakota and on both the participatory scenario planning, the qualitative scenario planning work, and the quantitative state and transition simulation modeling work that Brian will focus on that second part in this presentation, and trying to use these tools together to inform adaptation in the region. So thankfully, this project team has lots of great folks on it, including Amy and Brian. Others, Gregor Skierman, an adaptation specialist with the National Park Service, Leonardo Frid, who's really our state and transition simulation modeling guru on the project, Andrea Ray, who's our climate expert on the project, has been really helpful in identifying and selecting specific climate projections to use in our work. And then finally, Erica Rowland, sort of Leonardo's counterpart, except she's the guru in scenario planning, participatory scenario planning. This is just a quick look at our project team. And a little bit more background into why we decided to do some work in Southwest South Dakota, and specifically centered around Badlands National Park. And one reason is that there was a climate change vulnerability assessment done for the park back in 2012. And of course, assessing vulnerability is one of those steps in adaptation. And the park said, okay, great, now what? They asked. And so we wanted to continue to work with them to use the vulnerability assessment and to continue the adaptation project with the park and with other managers on the landscape. And so we thought we would bring in some of the participatory scenario planning that the National Park Service has been using since about 2009, and try to continue to improve that process. And then in addition, we saw this as an opportunity to also work with quantitative modeling and to bring that into the adaptation process here for this landscape. And to also, again, build on previous efforts. Amy had been part of work at Wind Cave in South Dakota that also had had a participatory scenario planning workshop, and then they did follow that up with some simulation modeling afterwards, and it was some simulation modeling that was done over multiple years, so it took a fair bit of time, and so our project here, we wanted to try to prototype some relatively rapid simulation modeling that could be done directly after the initial scenario planning workshop. So here is a map of the research area in southwest South Dakota. You can see the black polygon, that's Badlands National Park, and then there's also Buffalo Gap National Grassland and Pine Ridge Reservation, and then the purple sort of brain-shaped polygon, that's the project boundary for the climate change vulnerability assessment and also for the simulation modeling work that we're doing in this project. So here's just a flow diagram, a whole bunch of boxes and arrows for this project, and really the left-hand column, the white boxes with the blue trim, are really the climate summaries and the climate scenarios. And then the middle column, the red boxes, are the participatory components, the orientation meetings, the workshops, and the webinars. And then the right-hand column there, there's 3 green boxes. Those are the quantitative simulation modeling aspects of this project. And so these are all really linked together, building off one another throughout the project, which started in April of 2015, and we're trying to plan a webinar to end the simulation modeling work later this year. So for the first half of this presentation, I'll really focus on the the participatory scenario planning workshop, this workshop 1, and the orientation meeting leading up to it, and then that'll feed into the simulation work that Brian will present on. So the first step here, orientation meetings, we had some face-to-face meetings with managers in the region to get a better sense for the management challenges that they're facing, the kind of information that they need, and the critical uncertainties that they may be facing. And some of the key issues that came up during this process included things like erosion, grassland productivity, as well as invasive species and woody encroachment, and also grazing, both buffalo and, bison and cattle in the region. And then finally, some other issues of facilities and road maintenance tend to be some big issues for managers. Of course, this is the Badlands. These are highly erodible landscape, and so roads and buildings don't have to stay put because of that, and can lead to some very expensive maintenance. And then finally, some of the P&E species, such as the black-footed ferret, are a conservation concern and focus for some of these managers. So there was really a whole host of issues that they came up with. And we did try in the participatory scenario planning workshop to cover all of these issues. And then for the quantitative simulation modeling, we focused really on the grassland and grazing. So I'll highlight those especially here in this part of the presentation. So after the orientation meetings and understood some of the key issues they're facing, we then developed some climate scenarios. And just a quick refresher slide here on scenario planning. Scenarios, they offer a range of plausible futures. They're not predictions, it's not forecast planning, but they're providing a framework to support decisions and to assess some of the critical uncertainties in the future and let managers ask some what-if questions about the future. What if this future played out? How would I respond? What if that future played out? And so this is really the framework that we used in this project. So some of the key drivers we then identified, some of the key climate drivers we identified then based on their their management concerns, including the grazing and grasslands, include temperature, spring precipitation, heavy rain events, the growing season characteristics such as the last spring frost date, and then also soil moisture, spring and summer soil moisture. And so we use these variables to then create scenarios, climate scenarios. We developed 4 scenarios for this workshop, and we wanted these to be relevant and plausible and divergent and challenging. And here this bivariate scatter plot you're looking at has last spring freeze date on the X and change in spring, late spring, early summer precipitation on the Y. And these are a whole bunch of projections in individual GCMs, and the 4 colored squares are the 4 that we ended up choosing for this workshop. And you'll see we wanted them to be divergent but still relevant and plausible. I'll show you on the next screen 2 other variables that we also used in our selection. And it's one reason why we didn't just choose 4 scenarios, 1 from each quadrant in this slide, but we realized that there were other variables that were also important to managers. And so here's that second bivariate scatter plot showing changes in heavy precipitation events, both the number of days with 1-inch plus events and then the number of wet periods, so 5-day periods where there's at least 2.5 inches of rain. And again, you can see the 4 scenarios that we, or 4 climate projections that we selected here. So we took these 4 and then we gave them names. You can see them in the colored boxes in the top row there: rather hot, awfully dry, wet and bursts, and the jungle. And hopefully the names capture really the flavor of each of these scenarios. And then the arrows here that you see, the direction and size of the arrow indicate the types of change over the next 35 years in the scenario. So there's some commonalities here. You see temperature. All the arrows are pointing up, indicating an increase in temperature over the next 35 years. Whereas for some other variables, April to June precipitation, for example, you see some arrows are pointing down, others pointing up, showing that was one of those critical uncertainties in future conditions, is that late spring, early summer precipitation. And some of the projections suggest a decrease in precipitation, such as in the awfully dry scenario, and others suggest an increase in precipitation over that next 35 years, such as the jungle, the far right-hand scenario. So you see 4 scenarios here. There's some similarities, but also differences among the scenarios. Then we packaged these climate scenarios and then brought them into our 2-day scenario planning workshop that we held with managers. And this was in Rapid City, South Dakota. It was a 2-day workshop where we brought in several experts as well as managers from the area, and we brought in our climate scenarios and then worked with the group on those scenarios and thought about the implications. What are the effects to resources and facilities, to species of conservation concern, and then what might your management responses be within each of these scenarios? And so we worked through several different activities to help the managers there sort of jump in and roll up their sleeves and think about these different futures and what that might mean for the resources that they manage and what that might mean for their management actions. And so here's just an example here showing some of the potential implications, and the ones highlighted here are circled here related to bison and grasslands. So the columns are the 4 scenarios, and you see some of the implications here. Under the rather hot scenario, less forage, less water, potentially fewer bison, some similar implications under the awfully dry, whereas the wet and burst scenario, scenario with high interannual variability, suggested that there'd be a real management challenge in matching stocking rates to conditions and productivity of the grassland in a given year. And then finally, the jungle one showed some other potential changes and challenges, such as strong increases in some non-native species and implications for other species of conservation concern, such as the swift fox. So the managers and experts were able to look at these climate scenarios and then flesh them out with implications for resources. And then beyond that, we then used this aligning adaptation framework then to think about goals and actions and what might need to change in the future under each scenario. And so there are three different sort of adaptation options here. There's a business as usual, climate retrofit, and then a climate rebuild. And so within a business as usual strategy, it's one where current goals are achievable with current actions. So looking at, for example, management of the swift fox, and perhaps under one of the scenarios, through expert elicitation, the people in the work groups realize that current goals are still going to be achievable with current actions. Perhaps under another scenario where current goals may still be achievable, but there may need to be revised actions. Perhaps for fish in a stream, for example, maybe there would need to be additional stocking. So that would be a climate retrofit, where current goals but revised actions. And then finally, at the far right end of the spectrum here, you have climate rebuild. So a recognition that current goals probably are not achievable in the future, and thus not only do actions need to be revised, but the goals themselves also probably need to be revised. So we used this framework here, this aligning adaptation framework adapted from climate smart conservation in our work group exercises. And we found this one worked well for both natural resources and for cultural resources, as well as facilities infrastructure. And we did this for about 5 different resources, but here I'll just focus on bison and on just one scenario, and this is the jungle scenario. The current goals are to maintain a healthy and genetically diverse bison population, about 1,000 animals and 17 genetic groups. So there's the question, is this goal achievable in the short term, say in the next decade, or also in the long term, in the next 35 plus years? And so the work group for this thought that yes, this goal was achievable in both the short term and the long term, but they saw that under this jungle scenario that there are going to need to be revisions to actions. And some of the revisions to the management actions include some changes in how they round up the animals. This is a wetter scenario, and so the bison in the fall may be more dispersed on the landscape. It will be more of a challenge to round them up. They also saw potentially more bison, and thus better mechanisms needed to transfer bison from the park to others on the landscape, such as to the tribes. And then also with the warmer and wetter conditions, there's some strong concerns about pests and diseases and potentially the requirements for new vaccines to deal with some of the diseases for bison. And then there were definitely some interesting insights here. The managers really recognize that bison as a species is extremely adaptive. It's very accommodating of changing conditions. But that said, managers themselves will need to be as adaptive and responsive as bison in order to be effective. And in this instance here, this was really seen as a climate retrofit, so current goals could be achieved, but with some revised actions. And we did a similar exercise with these different resources, with archaeological and paleontological resources, vegetation, bison, black-footed ferret, and then some of the infrastructure and facilities. And it's, I think, a useful exercise, especially to see when is business as usual even an option, and how often does it come up, whereas how often do do managers need to think about revised actions or even revised goals and actions? And this is just a quick summary table here that you see often climate retrofits or climate rebuilds were seen as what was needed for a resource within an individual scenario. So moving beyond the scenario planning workshop, and this is especially true for other efforts where there isn't then the additional quantitative simulation modeling, there's different ways to try to operationalize adaptation. And these are some of the examples here, using some decision trees and indicators or thresholds, also evaluating options, identifying some of the no-regret options and hard choices and ways to work through those, and also disaggregating steps, taking some really big decisions, major changes, and disaggregating that into much smaller bite-sized pieces, essentially, and understanding then what needs to be done in the near future in order to make some of those changes that might take a decade, 2 decades plus to happen. This is just an example here of some of those next steps in adaptation after a scenario planning workshop. And I'll just mention the workshop summary for both the Southwest South Dakota scenario planning workshop, as well as one we did a little earlier in November of 2015 in Central North Dakota. Both of those reports are available at the very easy to remember URLs at the bottom of the screen here. Feel free to contact Brian or me to get copies of these reports. And so with that, I think I will be passing it off to Brian now, who will talk about the simulation modeling work that really steered off of the workshop 1, where we developed the qualitative scenarios and implications.
All right, thanks, Nick, for leading us in there with a nice description of the sort of qualitative, participatory portion of the work, at least for the South Dakota study site. So as kind of shown here, I'm going to talk specifically about the more quantitative elements of this project and the simulation modeling work in particular. And one thing that I'll say isn't shown here necessarily in this already complicated diagram, but that I'll talk about in a few slides is that really one element of this that was super important for I think making the model be realistic and also relevant to management needs was having a lot of interaction with managers and local experts on helping us put this together. So just an acknowledgement that this work is being done very closely with those folks. So as Nick showed earlier, this is kind of our study area, that purple brain type polygon. As you can see in the legend there is the project boundary that was used for the climate change vulnerability assessment that happened several years before this project started. And the reason it's the shape that it is that it was developed, there's a protocol developed by Andy Hansen and others at Montana State University who developed a way to define what they call protected area centered ecosystems, or PACE boundaries, that not only take into account the park itself, but what's sort of the relevant ecosystem processes and functions that are going on beyond the park boundaries. And so that's where we got that particular purple polygon, and that you might see again here in the results section for our modeling work. So why really bring this quantitative element in to begin with? As Nick showed, there's a number of benefits of even going through our qualitative work. And I would argue, and we've argued, and I think are now coming to show that there are certain things that, they're just limits to our brain power. There's a lot to keep track of in a scenario planning workshop and in these complex social ecological systems where there are a lot of interactions between different system components, and then you layer on top of that different climate futures, and on top of that different management strategies, and suddenly there's a lot to keep track of. And so, computers are like big brains that can help us to keep track of all those different interactions, and possibly, and sometimes, show us some unanticipated things that we may not have expected because of those complexities. so simulations can capture those interactions and also allow us to use then these sort of simulated landscapes as sort of a virtual laboratory where we can start to play with the system in a way. We can vary management activities by jurisdiction and over time, and we can track our variables that we're interested in over space and through time, and including things like cost, the cost of management actions, or how many acres we want to burn each year, or things like that. So those are sort of the reasons we've brought these simulations into play here. And in particular, we're using one type of simulation model. There's lots of different kinds. I specialize in particular in state and transition simulations, and apologies to those who have heard me talk before because I've given this background in other settings, but I think worth hearing for those that aren't familiar with STSMs, is that these models started as conceptual models back in the late 80s, and these are essentially ways to organize our thinking about rangeland systems, where the boxes represent states or sort of groups of vegetation communities, and the arrows are transitions, which are any kind of process that can move vegetation between those states. And that could be things like fire, grazing, or restoration, or invasive species removal, things like that. So that was how they initially were conceived of, and to some extent are still really used as organizing conceptual frameworks. But in recent decades, folks have moved toward taking those conceptual models and operationalizing them in software programs. And so these simulation models are stochastic. They're based on probabilities, so you're not going to necessarily get the same answer every time. And the real benefit here is that we can parameterize our models, allow it to run through time, and then sort of predict vegetation dynamics into the future with some uncertainty. And so what are the main inputs that we need? We really need two main things to create one of these models. One is the probabilities associated with our transition. So these arrows here, what's the likelihood we'll have a fire in any given year, or succession, or what have you. And you can, instead of probabilities, you can also specify transition area targets. So maybe it's not that we have a probability of construction happening in a given year. It's that, well, no, we know we're going to do X number of hectares or acres per year, and we can operationalize that in the model. So all the transitions now have values associated with them that dictate how likely they are to happen. And then we need to tell the model how much of our landscape is in each of these state classes at the beginning. Here it's in 2011. We have 3 state classes, and there's X, Y, and Z acres in each one of those classes. And then we use a software program, in our case STSM, to track a couple of things through time. How much of the landscape is in each of those state classes? How does that change through time? And how much is happening in the way of transitions over time? And as I said, this gives you some idea of vegetation dynamics into the future and how much uncertainty there is around those changes. So that's kind of in a nutshell how a state and transition model works. There are a number of optional model features which I want to mention because they come into play in our model, and that is a couple of things here. So one is sort of clustering. We know that events like fire or invasive species spread don't just happen randomly, spatially randomly around the landscape. Once you have an invasive species at one location, it tends to spread to adjacent areas more quickly than far away areas. We can also implement temporal variability in transition. So maybe we know that the likelihood of fire isn't going to be static through time, but maybe it's going to increase or decrease through time. One really, I think, useful element of these models is we can also vary transition spatially. So in our case, as we showed in the map earlier, we've got 3 different primary sort of management jurisdictions, the park, Pine Ridge Reservation, and Buffalo Gap National Grasslands. And they have very different management constraints and opportunities, and so we can sort of reflect those within the model itself. And similarly, we can set different management targets for different specific actions. So to build our conceptual model, so again, we have to start with our box and arrow diagram. We turn to the NRCS rangeland classification system. and this is widely used. And the rangeland classification system consists of two levels, you might say. So one is the ecological site, and that's depicted here on the right by 3 different groups: gravelly and gravelly loam, clayey, loamy. This is just an example. And these are sort of longer-term ecological, long-term sort of areas that represent ecological potential. They're driven by slower variables, generally fairly static through time. And so that's sort of one level. And then within each ecological site, as you can see again here in this map example, there are multiple states and phases. And these are more reflective of current conditions or recent conditions, and are pretty dynamic through time. And so for each ecological site, NRCS has provided what's called an ecological site description. And these ecological site descriptions contain a diagram, our sort of state and transition model, our conceptual model, some descriptions and photographs of what these different states and phases look like and how they behave and what their defining characteristics are. So this is a really great resource for us to build out our models. And that was our starting point. And so we could take here on the left is one example state and transition conceptual model. The screenshot here on the lower right is from our software program, so we kind of moved that model over. And then the trick to this is to now say, okay, for each one of these arrows, what is the actual number associated? What is the value associated with that given transition? What's the probability, or what's the management area target? And so that's where we really needed to turn to our local experts and managers to help out, because we can turn to the literature for some of those values. There's some published information on different likelihood of different things, but in a lot of cases there isn't. So we turn to local experts and managers in the literature. So first I'll talk just about one element that came from the literature, and that is incorporating climate and its influence on rangeland productivity. So the ecological site descriptions contain some basic information on annual production values for different ecological states. And so they've grouped it into sort of low, medium, and high production years. So a fairly coarse way to do it, but it's useful for us. It tells us how many pounds per acre a given state class is expected to produce under these different types of sort of years, so to speak. And then from looking at the published literature, we know there's certain climate variables that are especially important for predicting vegetation production. And those are the ones I've listed up here: spring precip, flag spring precip, and days until the last spring frost. And those are the variables that Nick showed earlier in those scatter plots. So we kind of realized this going into the workshops, that these variables were important for dictating rangeland production, and thus we use those to help us select our climate scenarios. And those are coming back into play here in terms of our quantitative modeling work. So, having that close connection between the quantitative and qualitative work was really, really important and really informative. So we've got these general sort of values, but what we want to do is figure out, going forward into the future, how many of these low, medium, and high production years will there be, and when might they happen in a hypothetical or scenario type of a sense. Not to say we expect these different time series to occur, but rather what are some example time series of what could happen that might support our scenario thinking. And so we can classify our future years into these different production categories, and then use the values from the ecological site descriptions to project forward our sort of production values, our very hypothetical kind of production values for different state classes. So that was one way we could bring in some published information. But like I said, a lot of our information also came from local knowledge. So throughout this process, we were iterating with folks. So from the very beginning, with even just our conceptual models, we were getting feedback on those. We put together an initial model for a subset of our study area and brought that to our first workshop and got some feedback on it. We also then sort of went back to the model, made some refinements, and did a webinar, and then went through and actually got a lot of our model parameters from the experts themselves. We had them fill out Excel spreadsheets and give those back to us, and we could use those to develop our transition probabilities. We then had another webinar to share these new model results right before our second scenario planning workshop, where we, as you might expect, got yet more feedback as folks kind of could dig into it and really start to understand what the model was telling them. And so where we're at right now is, actually as of today, I just was transferring the model results back over to my computer to look at the newest round of results. But I'll go ahead and show you guys some preliminary results here in a few slides. What were we looking at in the way of scenarios? So there were the 4 climate futures that Nick talked about, but then on top of that, we've got to multiply it by our different management scenarios. So we had 4 management scenarios named here, and these varied stocking rates, prescribed fire, invasive species inventory, and invasive species treatment. So a lot of variables that are changing across these different management scenarios. So as you can see, things are getting a little bit complicated. 4 climate futures by 4 management scenarios. That's 16 sort of climate and management scenarios, and then you've got, variation in more than 4 different variables within each management scenario. So suddenly you get a lot to keep track of, and that's where our simulation can help us to do that. So some just kind of preliminary results with the caveat that we've actually just revised the model and are getting some new results coming in. So I wouldn't take these results and run just yet, but to give you a flavor for the kind of things that we found to date. I want to bring back first this table that Nick showed and point out a couple of things. So there's the circles, both the red and black circles, just kind of indicate some different types of scenario implications that we might be able to assess with our model. Are we seeing a shift to tallgrass prairie? How about weed increasing? But for the next couple of slides, I want to talk a little bit more specifically about these 2 sort of drier scenarios where there's the expectation of sort of limited forage and the need to have fewer bison on the landscape. So those are sort of things that came out of the qualitative work. But what was interesting from running the quantitative simulations was that first, there appeared to be more forage available than expected in the qualitative exercises. Even under the dry scenarios, sort of the awfully dry and rather hot scenarios, the simulation has been indicating that there may actually be more of a sort of a buffer, so to speak, in forage availability than was previously thought. However, this idea of sort of a buffer in forage availability might have a trade-off. So having a conservative stocking strategy, maybe where you're putting fewer cattle or fewer bison on the landscape, that's great for those really dry years. You've got more standing biomass available for those bad years. But that also seems to come with a higher proportion of undesirable grass species. And we kind of see this when we look both across management jurisdictions, when we compare the grassland to the national park and reservation, and also across management scenarios. So here's a little graphic, just one of the many model output graphs. And this is showing you the proportion of each management unit that's in this cool season exotic grass space, so an undesirable grassland community type. And the different colored lines represent different management strategies. So here I'm just showing you three of the 4 different management strategies. And I'm also just showing you one of the climate scenarios. This is the awfully dry climate scenario. And the top panel there is the national grassland. And you can see that right off the bat, there's a lower proportion of this undesirable vegetation phase than in the national park, which is the bottom panel. And this is likely related to sort of having very different stocking rates in these 2 different jurisdictions. And that seems to be confirmed by the fact that when we alter the stocking rates by changing our management scenario, we're getting less cool season exotic grass under our highest sort of bison stocking rate scenario, that green line here in the bottom panel. So that's sort of giving you a flavor for the types of model outputs we're looking at and how we interpreted those with the managers to understand, okay, why are we seeing less cool exotics in the grassland, and what about when we change this management scenario, why are we seeing it drop within Badlands itself? So to kind of summarize the quantitative work, I think I'd note a couple of things. One is that we were able to kind of bring together both literature-based information and also bring in the local knowledge from experts and people working on the ground. the modeling itself, the state and transition simulation modeling, was fairly familiar to people. You know, they were at least familiar with those NRCS sort of conceptual models in a lot of cases, and we could produce a simulation with a relatively low cost and quick turnaround compared to lots of other simulations that take multiple years and lots of dollars and lots of people to put together. And now we're able to sort of compare the combined effects of climate and management scenarios, and in some cases this is having some counterintuitive results. And that's really where right now we've gone back, and now that once we get these new model results, go back and sort of interpret these again with managers and say, does this make sense to you? And maybe it's surprising, but is it at least plausible? And so that's sort of where we're heading. And I think general conclusions just from the work sort of as a whole in combining the qualitative and quantitative elements, I'd say that, talking with Nick and Amy about this and others on the team, I think one of the really neat things to observe sort of in the in-person workshops and also when doing an in-person workshop facilitated with the quantitative information is that people can kind of have this opportunity to look over the fence at different management strategies that are happening on, maybe land just next door, or, possible, but what if we adopt their approach on our landscape? What might that look like? Managers, of course, already talk about looking over the fence to think about noxious weeds and, maybe we're going to have a new invasive come in. But, we're fairly optimistic that this kind of approach opens a broader dialogue about, management practices in sort of a more landscape scale, regional scale type of a sense. The qualitative and quantitative pieces, I think, do provide some complementary information. And I think one of those sort of complementary pieces is that a lot of times in the qualitative exercises, or at least in this instance, I should say, there's I think a tendency for folks to, in some cases, really go to the doom and gloom kind of stuff. It's like, oh, we're going to have this super dry scenario, and then this is going to go wrong, and this is going to go wrong, and a fire, and it's going to be a huge disaster. And we encourage some creative thinking, and that really is a key part of the qualitative process. But at least in this case, I think the quantitative simulations help us to check those. Are those doom and gloom scenarios right? I mean, is that kind of what our best available knowledge is telling us? Or maybe we need to scale that back a little bit. And so they can kind of inform one another. And where are we going next? As I said, we're going to be sharing the results of our final simulations with managers here in the fall, and sort of return to thinking about management implications. What do those simulations combined with our qualitative work tell us? And then we're documenting our process and outcomes. Nick pointed to those National Park Service reports, and then we'll also be working on some peer-reviewed publications. And finally, we're also working toward a climate summary tool, something that we're working with some USGS hydrologists and also Parker Norton at the South Dakota Water Science Center to put together a more automated tool for people to create local summaries for this region with compiled data, so that in the future, if somebody else wants to go back and have another scenario planning exercise at a different park in the northern Great Plains, they could turn to this tool and say, hey, cool, let me produce some of the graphics like Nick showed earlier and bring those to some workshops and meetings in the future. So kind of trying to build some capacity for additional future work. And I think with that, I will stop and have an opportunity here to ask Nick and I questions that you might have about the project.
Jump in. I have a question, actually.
Absolutely.
On the spring precipitation that you focused on, was that strictly amounts, or did you look at like rain versus snow? I know probably the towards the earlier part of that season, but
yeah. So in this case, Nick was a little more intimately involved in the climate data processing and sort of interpretation, but to my knowledge, here we did not distinguish between rain and snow, but I believe for the most part this is, like you said, would be rain events. Nick, anything to add there?
Yeah, that's exactly right. And it was April, May, June, so certainly there could be some snow during that time, but it was just total precipitation.
Any other questions?
Hi, this is Imtiaz. Brian and Nick, thanks. This excellent presentation. I've been following your project for a while, and really good to see all the advancement here. So maybe a quick question. I mean, I don't have a specific question, but it's good to hear Brian talking about this the element of broader dialogue that these kind of work lead to that help the manager to look, as you said, across the fence. And I think that to some degree is integration of climate change thinking and maybe element of climate adaptation there. So one of the things, I mean, I kept going back to my work with the Southwest Colorado project where several components were there very similar to what you had. And one thing I struggled with as a climate expert there was, when they start talking about strategies, and I don't know how much you did in terms of talking about strategies, it was becoming difficult to kind of keep track of are they thinking along the different scenario lines, So when we're talking about strategy, somehow climate change thinking was a little left out, or they were not thinking that there'll be multiple climate scenarios. They were just thinking about a specific impact and went deep into the strategy, but despite realizing that the impacts may be different in different scenarios. So it was just a little difficult to kind of wrap our brains around how to bring the scenario planning there. And I think at the very beginning, our idea was that working with multiple scenarios was working across multiple risks that comes from different futures, and then developing a strategy would be like, a robust strategy would be that kind of works across multiple scenarios. But, as I thought more about it, there could be robust strategies that work across fewer scenarios, but then you can develop other strategies that may work across the ones that are left out. So I appreciate any thoughts you had.
Thanks, Imtiaz. This is Nick. I'll take a first stab, Brian, and thanks to Imtiaz. He did also give us some good pointers and recommendations on the selections of individual GCM projections to use in our scenarios. And I think one thing managers and the experts, when you get them in a room together, they always want to jump right to the solution and to develop the strategies, and you have to sort of try to keep them from putting the cart before the horse, and to first think about how might the future look before jumping into trying to solve the problems, and that can be hard, and that's, I think, also too where the scenarios can be useful, and that you get these work groups together where they have to actually flesh out the scenarios. We bring in basically the climate skeleton or climate framework, and then they have to then paint the implications onto that, and that helps to slow them down a little bit, and to recognize that the future isn't going to just go in one direction. It could go in multiple different ways, and hopefully with well-crafted climate scenarios that'll help to foster that thinking and get people to realize that their future could turn out a few different ways. Anything you want to add to that, Brian?
Yeah, well, first off, your first point is exactly what I was kind of taking some notes on here as Imtiaz is speaking. That just, I agree, there's a tendency to jump straight to the management responses and in the workshop. And so just having, really, I think, mentioning that to folks like, hey, I know it's tempting, but try and hold back on that just for this portion of the workshop. Let's focus on implications first. Was useful, kind of just making that explicit. Also good, having a good facilitator like Erica helps. And then we also changed up our groups a little bit, the breakout groups. So Nick, correct me if I'm wrong, but I think when we went through the climate implications, sort of the first stage, we had folks from different topical areas. Maybe you're bringing it together somebody who's thinking about bison with somebody who's thinking about infrastructure and somebody who's thinking about, in vegetation to think about the climate scenario implications for one of the climates, for say the hot, wet one. And then when we get to the actual management responses, people move to the groups that they feel like is their management focus. So, maybe we had a bison group and a vegetation group, and people could then kind of get together with others who are interested in management actions for a specific resource and look across the climate scenarios. So I think that was another kind of useful way to go about it. Nick, I don't know if you'd agree, but that was my only other thing I wanted to add.
Yeah, exactly. I think so. I think having initially those diverse groups where we usually the work groups are about five or six people, and we try to have a natural resource person, a cultural resource person, a climate science person, an adaptation specialist in each of the groups, so that there was a diversity of backgrounds and perspectives. And I think for people, the managers found that really useful, and also in the fact that they were talking to people with different backgrounds, and so they had to work a little bit harder to justify some of their thoughts on how the system would respond and why did they think that grassland productivity would increase or decrease, for example. And so we got positive feedback on having those diverse work groups.
Yes,
and then,
guys, again, no, that doesn't happen quite often out there. So I totally see the point there. And we probably had that ourselves in our Southwest Colorado project. One thing we would have benefited would be from using Brian's state and transition model in that project. I did talk to Brian about the possibility of doing that, but it somehow didn't happen. So maybe it could still happen in future. But I think they would have benefited by seeing some hard numbers through a model. Although we did use some Forest Service work on that showed, spatially explicit map of how the forest was changing under different scenarios. So, and we really found that those maps were really helpful to facilitate dialogues and amongst the managers. So, but I see the value of the modeling work. Thank you.
Yeah, and happy to still continue that conversation if you do want to pursue the same transition work. So.
Okay, thanks. Good to know.
Yeah.
Anybody else? We have just a few minutes.
Yeah, this is Rick Nelson in Bismarck. I have a question for Brian or Nick or both, I guess. So it sounds like a little bit that in the context of the work groups and how you approached it, that there was an implied use of for example, structured decision making. And yet you mentioned, managers always want to jump right to, management implications. Did you consciously build in structured decision making in those discussions with the understanding that what you really wanted to know from those folks was what information they would need to make the same or different decisions into the future? It sounds like it might have been there a little bit, but since you mentioned that they jump right to management stuff, it also sounds like that wasn't necessarily the way it was approached.
I would say it wasn't sort of explicit having the structured decision making, but some of the exercises we did then later after the scenario implications were fleshed out and we did the aligning adaptation exercise. We also then thought a little bit about a timeline exercise for decisions and they're thinking about some of the thresholds or trigger points, and working through that exercise was probably the most similar to structured decision making, where, for example, closing archaeological site to the public, what would need to be done in order for that to happen, and both going through the NEPA process and changes in staffing and changes in technologies and some of those trigger points that would need to be identified in order to take those management actions. So we didn't use a formal specific structured decision-making process, but certainly use some of those components in the exercises that we pulled together.
Thank you.
Yeah, thanks, Rick, for the comment, and a good one. And I think maybe something for us to continue a discussion about. You know, if you had some ideas of how we might bring in structured decision-making into a future kind of process like this, I think that'd be worth exploring. Something I'm less familiar with. It sounds like Nick knows a bit about it. Yeah, maybe there's some opportunities there to improve this process with some structured decision-making.
Yeah, I'd like to have that continued discussion at some point.
This is Andrea. I wanted to just jump in and ask a question. Nick, is the Park Service really using that formal STM process? I've also had some experience with that, but I know it's gotten to be a big thing in Fish and Wildlife. But is it big in Park Service?
It's not.
I think that's partly why we didn't really have that, except just kind of.
There are some examples, some parks that have used it for individual issue-specific projects, but it's not something that's used across the system. It's not something that the planning group for NPS uses systematically.
I think it's actually still kind of new, like only a few years, right, Rick, with the other management agencies, but because the Park Service wants to interact with the agencies in the surrounding areas, it might be something to pay more attention to.
Yeah, we're using it quite a bit in the Fish and Wildlife Service.
Yeah. All right. One more question, if anyone has one. Okay. Well, thanks to Brian and Nick for giving the presentation today, and to everyone for participating. Just one quick announcement. There will be no Adaptation Working Group webinar next month in October. We'll be in the middle of our PI and University Consortium meeting here at CSU during that time. So stay tuned for an announcement about November. And thanks, everyone.
Thank you.
Come on.
Thanks all.
Thanks.